Okay, so the second part was to consider g of x equals, what was it, 3x minus 5. This is a lot easier to graph for us algebraically. It has a y-intercept of -5. It has a slope of +3, so 1, 2, 3, and over 1. Okay. 1, 2, 3, and over 1. Okay. Is a straight line. Pretend that that is a straight line. Okay. What is the slope of this line? Three, right? Yeah, so the slope is 3 all the time. That's the nice thing. That's the nice thing about lines, right? Lines always have the same slope. What's the slope here? 3. What's the slope here? 3. What's the slope here? 3. Here, 3. Down here, 3. Lines, they just have a constant slope. So what do we imagine that g prime of x is going to be? 3, right? It's always 3, no matter what x is. What does that look like? It's a flat line, right? It's just always 3. The slope here in G is always the same. It's never changing. Never changing. It's never 0. I don't ever have a slope of 0. So it's never flat. It's always increasing, and it's always increasing at the same rate, the rate of 3. So it's just always 3. So I didn't have to go through the trouble of evaluating the limit. But if I wanted to, it wouldn't be too hard. Here's the definition of the derivative. G of x plus h minus g of x all over h as h goes to 0. So g of x plus h is 3 times x plus h minus 5. I'm going to put that in brackets just so I can identify it as all of g of x plus h. And then I'm going to subtract g of x. I'm also going to put that in square brackets so that I can identify it. And remember, g of x, it was 3x minus 5. You see it there at the top of the screen. 3x minus 5. So there it is in brackets. And then I'm dividing all of that by h. And now I've kind of filled in the paint by numbers that is this formula, right? I've filled in the template. Now I just need to simplify the numerator, and hopefully there will be an h that I can yank out and cancel with that nasty h in the denominator. So 3x plus 3h minus 5 minus 3x plus 5. Right? I'm subtracting that entire expression. It's all over h. So all I've done here is distribute. And now I can add up like terms. Minus 5 plus 5. Awesome. 3x minus 3x. Awesome. So it's just the limit of 3h divided by h as h goes to 0. And h's, those will cancel. They're both factors. So that's just plain old 3. Which is great because that's what we knew from context. Questions here? This leads me to something that's fun for us that are lazy, like me. Here are a bunch of functions. F of x equals 2x minus 4. G of x equals 9x plus 10. H of x equals pi x minus e. P of x equals negative 3x plus 4. Q of x equals negative 1/10 x minus 4/3. I don't know. Here are 5 examples. F, G, H, P, and Q. And now, in a hurry, in a flash, let's find their derivatives. What's the derivative of f? 2, right? It's a straight line. It has a slope of 2. It always has a slope of 2. Therefore, its derivative is going to be 2. What about the derivative of g? 9. And the derivative of h is pi. And the derivative of p, negative 3. And the derivative of q is negative 1/10. Right? Right? The slope is always the same for a straight line. So their derivatives are really easy to determine. Their derivatives are always the same because the slopes are always the same. What about this one? What about r of x equals 10? I heard 0.
I don't think there is one.
Why not?
Wouldn't that be vertical?
No, so y equals 10 is a horizontal line. Okay. X equals a number are the vertical lines. So y equals a number are horizontal. What's the slope here? What number is in front of the x? What if I wrote this? 0 times x is 0. Right? So now it looks like a line. 10 plus 0x. So what's the slope of that line? 0, right? R prime of x equals 0. What about s of x equals 2? What's the derivative of s? 0. Right? S of x is always 2. S isn't changing. If it's not changing, then it's going to have a rate of change of 0. Here's it not changing. Okay? It's a flat line with a slope of 0. So derivative is 0. Cool, huh? All right. We are well on our way to taking derivatives more quickly.